Chandler. I'm
This
here
is
for the sound check.
Awesome.
Or not the sound check, the computer check.
Chandler Abraham.
Me.
Yeah.
I got my own computer.
Straight up HDMI?
I got HDMI.
Great. So.
And the other one too on the other side. Your display port.
No, we'll just go straight HDMI.
Oh, cool.
So your laptop.
Alright. This is mine.
Get back more if you want. And go. Yeah. Then I can use it. Just hit the thing. Hit the thing. The two thing. Okay, great. Yeah. Okay.
Just know I got you, man.
Oh, all on it.
I got you, man. I don't know what I'm doing. There's all stuff I'm seeing on TV somewhere.
It's all, yeah, no, it logically makes sense. It's
Someone
fine.
says it.
Oh, it is projected. Okay.
Oh, I see. Sorry, I thought it was like
Oh, no,
a screen or
No,
something.
that would be amazing. That would be pretty impressive.
Cool.
Are you
Okay.
Do you need to tune your color in any way since you're giving actually a color top?
Audio? No audio. I'm not sure there's much I can do about the color because it's just going to be the projectors,
Yeah.
doing its best.
Yeah.
Is this a clicker I can use
Yeah.
somehow?
Yeah. This
Looks like it's a little. I think my HDMI is a little touchy. So
You keep hitting that button, right? Or you've hit that button.
Oh, it came back on.
I think it's. Touched it?
I think it's just. I think mine.
Well, don't touch it right now. We'll see if it does that again. We'll just leave it. We'll leave it for a second.
Do you think, just in case, I could just share my slides with you, just in case you want to cut over? Oh wow, that just works.
Yeah.
How?
It's like a keyboard.
Okay, crazy. Okay, cool. So we're set up. I'm gonna share my Google thing with you, just in case I end up having any troubles with this.
Yep.
Can you put in your email address right there?
Send. Sending.
Cool.
Sent.
Great. Unplug this.
HDMI. Invitation to edit. Ooh, I can edit your slides.
Yeah.
Okay.
Great.
They are here. We're back up. Chandler. Check.
Track has enormous A. You can see again. I don't know if I've actually seen a 15-inch of the new Pros before.
Really?
Yeah. Yeah, I'm ready to do a baby check whenever you're ready.
Okay. I am not quite ready. Maybe I'm ready. It seems not tight. Maybe it's tight. Alright. Kind of scared. I should probably just have.
Are you trying to get it to stand up or?
Oh no, I think
Yeah.
yeah, but I don't think that. Okay. You have your computer?
Yep.
HDMI, Michelle? Michelle? Can we get HDMI switch?
Monitors are in the right place and everything, so yeah, we're good.
You good?
Yep. I have no sound or
Michelle, can
anything
we
special.
HDMI one more time? Do it the other way. Okay. How's it going, Bryan?
How's it going?
Everyone listening? Good. I saw you were giving us
talk, I figured I should show up.
Yeah.
I didn't even realize it was the second birthday.
Actually, we're gonna need a wired mic. Maybe. No, so we're gonna have ukulele. Actually, we should wait. Maybe it'll be. Okay. Never mind. Is that the kimchi something balls? Fries. Are the fries? I want to get food. Maybe. Oh, no, I can't. Hello.
I'm one of the speakers for tonight.
Yeah.
If anything's set like
Yeah, you want to try out here? Hello, hey, how you doing?
good.
You want to test out your ID?
Yeah, sure. I do not have sound.
Okay.
I'm not fancy, so.
Okay.
Oh my fucking god, are you serious? I left my computer at work.
How are your slides? How are your slides?
They're Google slides.
Log in or something and send URL?
Sure. Where can I log in on?
Actually, you can probably find them on your phone. You have like Google Slides on your phone. Or Docs or Slides. Yeah, very cool. I want to try. How you pronounce it? Biden?
Lighting.
Yeah. Okay. Business. Nice to meet you.
Nice to meet you too.
What do you have?
Is there live?
Yes. Should be someone speak food.
Perfect. Okay, cool.
And then, yep. It's that, and I think yeah. Yep. You're having fun, aren't you? I can tell you're having.
What's that?
I can tell you're having fun.
Oh yeah, I'm definitely like
Is that the right resolution, or do I need to?
You can check what the resolution is. It's probably pretty high, which is totally fine. The preferred one. Yeah, you're fine.
Okay. So I was gonna do.
yeah, me too.
I can't just plug my phone I don't care, whatever's easier.
I would turn off like
Okay, so I said export.
you good?
Okay.
I can also offer my laptop if it helps.
Yep.
I can offer my laptop if it helps.
That should work. It'll all work out, don't worry.
Said your address is not found.
I actually said not to tell. Got it. Oh man, request access. I've gotten the thing that asks for access. Oh, wait. You know what? Hold on. Sorry. Hold on. No! Ugh. Okay, sorry. Either of those. I think you say deny if you want. Anyone would make it, right? You can also do, okay. Were you doing that? Did you go back to that? Okay. So yeah. Yeah. And then this will probably be plugged up. Yeah. You are second.
I jacket with the rest of my kids.
You know, doing alright. How about you? Did you like it? Oh yeah. Don't ask. No. Yeah, no, me too. I don't even know. I don't even know what happened there.
Business. Family. Hey, sash.
Yeah.
Like this. Is that good? I should take my back in the box. Oh, yeah.
Hi. Nice hat. Sorry, I was walking from dinner and it turned the video on. Yeah, we went to Smart Tokyo Yeah, that's that okay?
We're gonna need a wire, like, or do you want to do the wire? Do the wire. Excited. Ukulele.
So I got everything set up to be able to stream. And I figured out how to stream the same content to Periscope, Twitch, and Mixer at the same time. And then so I was thinking the next thing I want to do is if this works out and like people like it, and I can get a capture card and jack into the switcher, and then do a picture-in-picture of like what they're doing plus the live video. And I almost brought my like studio mic and everything, but I didn't.
You can also just get you can probably patch the audio.
Yeah.
Yeah, come down. Yeah.
Oh yeah. That makes sense. Yeah, so do that. I have to get like a mixer or something. But yeah. Yeah, I got everything set up to try to stream too. But I don't know what angle is good. Like a second angle.
What's that?
Which one would the boom go for? The boom for the ukulele or? Okay.
Lovely.
So arrange this how you would like it.
Here you go. Right here. Alright, we can put it Last time it was a long time ago.
I knew that was going to happen. I was like, You do it wrong, it's not
This is the best thing I've seen. I love your talk.
Yeah, that's like a nice monitor. You really even can. Yeah, that's fine. What do you do with Greg? Airplane. You good? How many? Yeah, the question was how many you want to do? I don't have any advice or guidance for you.
I haven't used my phone tuner in a long time.
Attention, Logical JS. I have a very important announcement to make. If there is a party hat in front of you that is not being worn, it is mandatory to put it on. Partying will be commencing. Thank you.
I'm not sure if that's really cool or like it's like a song. Have you been to not everyone can get that. They're really going all out here. How long have you been back? To the best of my recollection. I think I've been to like maybe like
So there's this. It's one of those evenings, I tell you. Tell you what. I mean, in terms of evenings, it's the evening and walking to that's what I'm trying to say, basically. Yeah, no, I mean, I'm early on, I was going with that. I just want to say hello. I just want to start that conversation. I just want to say, happy birthday! Thank you! Yeah, happy birthday to all of you. And now that I kind of started to have your attention, I think you might be trick. Heavy's ukulele too. Hush, everybody audience.
Hello. I'm playing 2 songs, one now and one after intermission. Yeah, that's the other time. This song is called Youth, and it's by a band called Daughter. Shadows settle in the place where she left. Minds are troubled by the emptiness. Destroying mental, it's a waste of time. From perfect start to the finish line. If you're still breathing, you're the lucky ones. 'Cause most of us are heaving through corrupted lungs, setting fire to our insides for fun, collecting names of lovers that went wrong, lovers that went wrong. We are the reckless, we are the wild youth, chasing visions of our future. One day we will reveal the truth. The one will die before he gets there. And if you're still bleeding, you're the lucky one. 'Cause most of our feelings, they are dead and they are gone. Setting fire to our insides for fun. Collecting pictures of the flood that wrecked our homes. It was a flood that wrecked this home. And you caused it. You caused it. Life lost it all, I'm just a silhouette. A lifeless face that you'll soon forget. My eyes are damp from the words you left. Me in my head, and you broke my chest. Ringing in my head, you broke my chest. And if you're in love, then you are the lucky ones. 'Cause most of us are bitter over someone. Setting fire to our insides for fun, to distract our hearts from ever missing them. But I am forever missing him. And you caused it. You caused it.
Sorry, it's so original. Thank you, that was amazing. Yeah, amazing. I know I speak for everyone here when I say that. But
Hello. My name is Emily. Hi. Hello.
I'm Disney. There's also Bryan and Michelle. Update these slides. Max. I don't know what else. Max is right there. Katrina's over there. Billy and Kelly are probably near the door. So we're organizers of this thing.
What we need to say is we're everywhere. So be prepared. So so welcome to Waffle.js. Real quick, just out of curiosity for myself, quick show of hands. No, okay. Okay, so maybe 4 or 5 of us have been to Waffle.js before, or we're paying attention, or have tired of that joke. So cool, so basically the way it works, we have 4 10-ish minute lightning talks, and then a little bit of intermission, and then some more talk. So today we have Bryan, and then we have Tilde Ann, and then Evie will be doing another lovely ukulele performance, and then we have Vaidehi and then Chandler finishing up because we're all friends here. So that's a lot all packed into 2 hours. So if you have questions for a speaker, just find them after their talk or during intermission, and keep the show moving along.
So afterwards we go to Butter, which is a block away for karaoke. The KJ.
Yeah.
Karaoke J.
Yeah.
Karaoke J. There's amazing.
But it's weird because you think his name is Jay, it's actually Roger, which is weird. But yeah, his name is Roger now. He's good. You should check him out.
So we do that. It's
Yep.
a lot of fun.
Yep. We do that. And this is how many? We actually kind of sort of know the number this time because there's been 2.
Oh yeah, you know how many? It's 23. This is 23rd one. So this January.
Because I was going to be off by 1. Boy, would that have been an error. So
counting from -1.
Yeah. Oh yeah. The index starts at 0, kids. Remember that. Anyway, it's first Wednesday of every month. It's always in this nice, cozy little barn, usually. Although not if I have my say. Sorry, that's another issue entirely. Anyway, the next one is next month. See how that works? It's monthly. So September 6th, and you can bring your friends or your coworkers or your pets, or your coworkers' pets, if they're okay with that.
Your pets coworkers.
Yeah, right. If you're pet coworkers.
Thank you.
Yes. Submit a talk or submit a performance idea. You could do that, and you should, because it would be great to see you here.
It could be bad jokes for performances.
Yeah, I mean,
because we don't have enough.
as you can tell, we do not have enough. All right.
Special shout out to all the people who bought student sponsor tickets. They pay twice the price so that a student can come here and have a round waffle, hang out with all of you, because we think that actually just learning things like computer programming it's part of, a lot of it's networking, and so getting people here, meeting people, and encouraging them to do cool things is part of being a programmer.
Networking. We don't need Ethernet. Ooh, I get to do this part. So this is the code of conduct portion of our evening, which I know is the highlight of everyone's evening. What this means is, we have an interactive code of conduct experience. So we expect you all to follow the JSConf code of conduct, and if you've never read it, you probably should. But in short, Waffle.js is dedicated to providing a harassment-free meetup experience for everyone, regardless of gender, sexual orientation, disability, physical appearance, body size, race, age, or religion. We do not tolerate harassment of attendees in any form. Sexual language and imagery is not appropriate in any medium, including talks or even just casual conversation, or even during or after the event. Waffle.js participants violating these rules may be sanctioned or expelled from the meetup without a refund at the discretion of the organizers. If you see, hear, or overhear anything that makes you uncomfortable, please find one of us and we will do what we can to make it right. And as always, please remember to drink responsibly. That was good. Bring it right back home. All right, so basically, we're not terribly, we're not trying to say this is like a big deal and you should be like super serious face, but things can happen, and if they do, you can contact us in a number of ways. Did you want to jump in? You jump in. No?
Yeah, you can DM us, the direct message us on the Twitter
web
service.
Yep.
At Waffle.js. You can let a co-organizer know. We went over all those details again. We are everywhere. You can announce me text 650-735-0005. That again is 650-735-0005. Or actually, I was reminded, if you see an emergency, call 911.
Yeah, yes.
Hang up the phone and call 911.
Yes.
Otherwise, yeah, that. Or if you go to wafflejs.com/conduct, you can type in anonymously and say something there, and it will reach all the organizations.
All the P1s. Yeah. So there's that.
Sponsors. Okay, this is a sponsored event, and that's actually just a way to say that we take sponsors' money, use some of it, and then give away all of it to charity after that. I put this in here so that I would be forced to do the numbers and then present how much we gave last time, and I won't do that. But I will next time.
I mean, kind of, relatively speaking. Compared to nothing, it's a lot. So
this is
but if you don't trust us, it's a spreadsheet.
Where's open door? I am open door. Ooh, here we go. I'm open door. I'm gonna do this. Does this work?
This works. Okay, wait. So I work at Open Door. What is Open Door? We buy and sell homes. We're a company that just buys and sells homes. That sounds kind of boring to a solution. It's a boring solution to a problem that is in the state. The real way to pitch this is to talk about what problem we're actually trying to solve. To do that, I'd like you to meet Mary. Mary wants to move from Phoenix to San Francisco. The thing is that she owns her own home. You're like, wow, Mary's got it well off. But no, like, median home price in Phoenix is actually $400,000. It's very different from San Francisco Bay Area. So she wants to sell her home and get on with her life. That's going to take time, it's going to take worry, it's going to be risky, and even if Mary fixes up her home and finds a realtor to list it, they get to open houses, the offers she gets might not even be great ones, and all that start to finish, on average, takes about 3 months or more, specifically in Phoenix. And again, that's assuming she gets an offer, 20% or 1 out of 5 offers fall through. So this is where Open Door can help use computers and humans to value her home, and if we're correct about the price, Mary can just sell it to us. And she can get on with doing the things. Fixing it up, listing it, nor ever like other strangers. Mary chooses what it close, 3 days to 30 days, and then hopefully Mary's happy customers. So what we do with Mary's home is we just want to sell it. So we take Mary's home. It turns out that it doesn't have to need some work, so we fix it all up. Then we actually list it. We're also brokerage, and now because we own the home. And Mary's already moved out, we can do cool things like let people in 7 days a week, buyers can visit when it's convenient for them, like after work, or with family, or with pets. And when the right buyer buys Mary's home, falls in love with it, they can buy from us with the exact same little hassle. So that's, again, what Open Door does. We buy and sell homes. Sounds pretty simple, so I just went through that in like a minute, but it's totally not. There are a lot of really annoyingly hard problems in there to solve. So we have to value homes accurately without ever really seeing them. So this is a pretty fun machine learning problem. We have to hide a bunch of real estate transactional complexity when we acquire the home. We have to fix them up really quickly, efficiently, and consistently. We have to allow access to well-intentioned buyers without being not well-intentioned ones. We have to hide a bunch of real estate transactional complexity again when we resell it. And we do, again, all of that with software and a little bit of hardware. We've only released on the surface. We have a lot left to build, so if you're one of these things, which probably are, I would assume, maybe, then please talk to me. Maybe. That's it. Oh yeah, this is Coco. You can take Coco also. That's me. Okay.
Next sponsor was it? I think it was Run Kit. Pretty sure it's Run Kit. Well, let me do the plug. Yeah, it's Run Kit. Run Kit's not here, but they made this really great slide for us to show.
Wait, hold on. Yeah!
And then you can like do this to it. Or if like you're really feeling. I'm just using up some of their time, but if you're feeling, is it a marquee?
Yeah. Look at that.
Wait, I got this.
I'm sure you are all just as sad as I am that the sponsor didn't make it here to talk at you. But let me tell you, Run Kit is actually pretty cool. So if you find yourself with a couple spare cycles and you want to check out something cool, not now, but like later, you can do that.
Wait.
So please consider this me standing in lieu of Run Kit.
Where's my dollar sign? Ooh, $100 signs. Ooh, wait. Okay, it's gonna be
Things just
better.
got really serious.
Did my dollar sign come back?
I mean,
They stuck a semicolon.
it was like a red background. It was like it's a klaxon.
Would I really? Wow, I'm not doing anything. Aww, I blame Safari.
A for effort.
Oh well, I was gonna go through a rainbow. Whatever, Run Kit, yay!
Yay!
Okay, Sparkles.
Oh, I've heard of them. So Mary is here for the Sparkles. Hi, Mary. Mary has a demo.
That was a way better demo than
Just kidding. that was the joke. Because there isn't a demo. So that's why it's fun.
There we go.
Okay. Yeah. Well, I thought it was fun. Jeez.
Hey.
Part of this.
Hi. Okay, this happens every time. And I told Vishnu tonight that we don't need to actually test it because every time we test it, it doesn't work either. So there's no point in testing it. And apparently it's worse tonight than it was before, so I apologize, I was wrong. Because now my PowerPoint disappeared altogether.
Hiding.
So I'm just going to talk at you instead.
It's a PowerPoint dialogue up there. Do you have an error?
Those are the scripts I was running earlier today to find out GitHub stats on who's using SparkPost and GitHub and our repos.
PowerPoint crash.
Hey.
PowerPoint crash. Someone. I think that's PowerPoint.
Alright, so you can plug your computer back in.
You don't need it?
I'll just talk.
Okay.
So, hi, I'm Mary. I am not the Mary that was in Open Doors demo. I actually live here, not Phoenix. I don't ever want to live in Phoenix because it's way too hot and I like San Francisco better. Anyways, I work for SparkPost. It's a very bright light. We are an email delivery platform. So we have an API. So stand over here because you're blocking the light for me. Thank you. We are an email API for delivery. So we basically handle all of the transactional emails that you send. So receipts or signups or building a Spotify playlist with your friends, which I demoed a couple weeks ago, or running an email raffle, which I demoed last month. I do not have a demo tonight. Emily lied.
No, this is the demo.
This is the demo. There we go.
How rock solid you are. I mean, you just didn't phase you at all.
Indeed.
That's a demo right there.
We love sponsoring Waffle.js. We love Waffle.js. Happy birthday. We're also sponsoring Queen's JS tonight, and it happens to be their third birthday as well. So we've been having a lot of fun with that. So I brought birthday presents. So we always have awesome stickers on the tables, but we brought webcam covers for you all tonight as well. And the running joke on the East Coast was that the webcam covers are free, so there's no cover charge. There we go. So enjoy your webcam cover. Let me know if you have any questions about SparkPost. There's a link to sign up for a free account on there. We have developer accounts for anyone who wants to test things out. And yeah, have a great night. Happy birthday.
Our first speaker is Bryan. Hi, Bryan. Oh, this is going to be good. This is really good. This is good news.
Did you want a cookie?
Nah.
No, you're good?
Actually, yeah.
Yeah? Okay. 1 second. Hold this.
Works for me. can't reproduce. No, no problem, right? Bryan, you're getting worked up over nothing, please. Please. I know, I typically do that, don't I? Well, you didn't bother me. Hi everyone, so my name is Bryan Hughes. I'm Nevergus on Twitter, GitHub, and like all the things. And I'm a technical evangelist at Microsoft. And I'm also really involved in the Node project. I'm the chairperson of the community committee, and I'm a member of the technical steering committee. And today we're going to talk about privilege, that light and fluffiest of topics. So I'm sure you have been in this situation before on one side or the other of the conversation. So you have a user, and they're using your application. You say it's a web app for the sake of argument. And they run into a really critical bug. Let's say maybe they try logging in, and as soon as they hit the login button, there's a crash. Or maybe some of the UI is off screen, and so they can't click on some of the controls. But like, there's some sort of bug that prevents them from using the application. So, perhaps kind of frustrated, they reach out to support, and they let support know that this is happening and file a bug report. So then support takes it over to the development team and says, hey, take a look at this. Our user here is having a problem. So then the developer takes a look at this bug, they look at the steps, they try and reproduce it on their machine, and nothing. It works perfectly fine. They can't reproduce. So then they close the bug and mark it as can't reproduce and move on with their day. Now the thing about this though is that user actually encountered that bug. Like they actually did get stuck. And when the developer closed that bug, they're basically saying, well, you're not really important enough for us to fix it. And usually the reason we have these kind of bugs is ultimately a difference in context. If we look at a lot of web developers, especially here in the Bay Area, they tend to work at well-funded companies. They're running the fastest high-end MacBook Pro you can get. But user may not be. It's entirely possible they're working at a company without a lot of money, and so they've got some 10-year-old PC running Windows XP or something like that. And because of this difference in context, maybe the slow computer exposed a race condition that the faster computers didn't expose. Or maybe it's an outdated browser that just works a little bit differently. Whatever it was, though, there's a difference in context. And a lot of times this context is something that the individual people involved didn't even have control over. It was decided for them by the company. And we see this in a broader sense, too. When we look at just navigating throughout society, there are bugs in society. We see this all the time, especially in politics and things like that. Politics is all about trying to fix bugs in society. At least that's one way of viewing it anyways. Perhaps we're too generous. But we have the same thing happen here. Everyone is navigating through the same world, but we all come from a very different context. We grew up in different places, different socioeconomic backgrounds. We're people of different colors, we speak different languages, different genders, sexual orientations, and so on and so forth. And all of these things together combine to create the context that we move throughout this world in. And based on that context, sometimes we encounter these bugs in society, and sometimes we don't. And this is basically what privilege is. We can think of privilege as being context we exist in just happens to be one that avoids these bugs in society. And when we lack that privilege, it means we are exposed to those bugs. And the thing is, though, just like bugs in software, there are bugs of all different kinds of level in society. Some of them, would be tagged critical. This is a really serious issue. We can look at civil rights issues in the past and things like that. But some of them are still important, but perhaps less so. And viewed in a vacuum, sometimes are not a big deal. A really good example of this is whenever someone refers to all developers as guys. If you look at that single incident in a vacuum, it's not that big of a deal. I wouldn't classify that as a critical bug in a vacuum. But the thing is, it doesn't exist in a vacuum. It exists in this broader context within the world, one in which women on average are paid less than men, are passed over promotion by men who are less qualified, and so on and so forth. So when we look at this in this broad context, and even if that one incident may not be a big deal, it adds up to this bigger problem. And we can think of that web application that we've all used before, where there's no major bugs in it, but there's lots and lots of little bugs. And it affects some people more than others. And those things can really add up. Even if each one in isolation is not a big deal, it can add up to this thing where you're just not able to be productive at all. It's seriously hindering your ability to work in that app, or in this, my analogy here, navigate throughout the world as a whole. So it's a little bit of a corollary to this that I also want to mention. Whenever you see someone from an underrepresented group that is like calling out an issue, especially publicly, that is never the first offense. Rather, that is the first hill that is worth dying on. So, like as an example, I'm queer and an atheist, and I grew up in Texas as well. So, that was some oppression in my life. Of course, also I have a lot of privilege as well. But like I've run into a lot of issues in tech related to my orientation. There's a lot of homophobia even here in San Francisco, believe it or not. And I don't call out everything I see. In fact, I don't call out the majority of things I see because if I did, that's literally all I would spend my entire day, every day doing. And this is true of everyone. We want to live our lives, hang out with our friends, write some cool code and stuff too. So whenever you see someone calling something out publicly, understand that is always just the tip of the iceberg. For every one thing you see, there's 1,000 more that were not reported publicly. And so, getting to privilege, I've made it all obvious already, like privilege informs how we see this world and how we move throughout this world. It's like a lens that we view through. It's like looking through a pair of binoculars. All of these experiences that we have lead up to this very specific view in life. And we all have this, like every single person here in this space has some form of privilege. In fact, we have multiple forms of privilege. But most of us also are lacking in privilege in some way. And these happen in different combinations as well. And that combination of privilege and lack of privilege adds up to this view we have of the world. To this lens that we view everything through. And it colors every interaction we have and the way we interpret everything. But also, no two people have ever had the exact same lens. We all see the world a little bit differently. First of all, there are different things that we see. Sometimes we just don't even encounter the bugs that people encounter in society. But sometimes we'll see them, but we'll have a different interpretation or understanding of them just because of all of this background life experiences. And in and of itself, privilege is not a bad thing. Like I said, everyone has privilege here. And everyone also lacks privilege. Where we run into real problems there is this leap of logic that we all too often make. And whenever we have privilege, we'll often say, well, this thing isn't a problem for me, therefore it's not a problem generally. And if that's the leap of logic that is actually really damaging and hurtful, and we have to understand that just because it doesn't happen to us doesn't mean that's not a real issue, that's not a real bug. Just like that user at the beginning, they really experience that bug. It really does happen. And so another corollary to that is we have not achieved real equality in our society yet. Racism, sexism, homophobia, and on and on. These are very much still problems that we are facing. We don't live in a post-racial society, as some people like to say. And so for the people who like to take the approach of, well, I'm just going to treat everyone exactly the same, typically with phrases like, oh, well, I don't even see color, I don't even see gender, that is not helpful. That is actually actively setting us back. Because the reality of the world is that we're unfortunately not equal yet. We're getting closer and closer all the time, but we're not there. And most of the world does not see it all this way. And so whenever we sort of take this approach of, well, I'm just going to treat everyone the same, that means that we're ignoring the problems that exist. We don't fix problems by ignoring them, we fix them by understanding them and actively working to make it better. And so the way we do that really is through empathy. We do this through dialogue, we do this through conversation. None of us can ever fully understand a given topic just by ourselves, using our own perception of the world. And so the way that we do this is we talk to other people, we listen to other people. We especially listen to the people who lack this courage, people who are experiencing the bug. Because they're going to know better than anyone else exactly what the problem is. But the thing about that also is we have to start from a position of believing people. Like whenever someone from an underrepresented group says that there's a problem, our first reaction should be to believe them. Say like, I believe you, tell me about this, I want to learn more, and then let's work together to fix it. But a lot of times, we do unfortunately see people who say like, okay, you're having this thing, tell me about it, but it's sort of done in this effort to disprove it. So we have to be like honest and open to actually listening to what these problems are. And that's how we really move past this. This is how we get all the different lenses of all the different people, and we look at a subject from multiple angles and really and truly understand it. Because that's necessary. That's how we move forward.
the tech industry is in a really interesting place these days, in that the tech industry has the ability to change the world more than anything else, more than any other industry. I think by quite a pretty big margin. But the question that a lot of people either don't ask or haven't answered is, are we changing the world for the better or for the worse? And that's a much trickier question. That's one where I don't think we're actually changing it for the better, or at least not a lot for the better. But we can. Like, the tech industry has that ability because of our reach. But the way we do that is, if we want to make the world better, the first thing we have to do is understand the world. We have to understand what the problems are in the world before we can start to fix them. And the only way we do that is if we get as wide an array of voices and as diverse set of voices as possible, so that we can take all these different lenses in the world and focus them on this one problem. And then finally, once we have that understanding, we come up with like actual solutions to fixing the world's problems. And I really do believe that is something that we could do. At least I hope we do it. Maybe in my lifetime, maybe not, but I think we can do it eventually if we work on it. But the thing is, this all starts with having empathy. This comes from recognizing that a lot of people struggle in a lot of different ways, and we need to understand and respect that, and listen and work together so that we can really make everything a lot better. Thank you.
Uh-oh. The TV broke. I'm sure there's a joke in there somewhere, but I mean, this is a serious topic, so we're not going to make jokes. No, I mean, it's one of those things. Yeah, it is a book. But you know, this is the moment in time where typically I would make a couple jokes and be silly. But I do have a personal policy. Some of you heard me mention this before. I have a personal policy about making jokes all serious. So you're gonna have to make your own jokes, folks. I'm sorry. That's all I have to say. But please, a very round form of applause.
I love this photo.
No way, that's you? I mean, I can definitely see the resemblance, but I feel like you've changed more than most people have. From youth. That gives me hope that maybe someday I can be comfortable with sharing baby photos of me. Because I try, and people are just like, this isn't you. And I'm like, trust me, that never-ending darkness really is me as a child. Anyway, wow, that got too fast. Please, with no further ado, Tilde Ann. Am I saying that correctly?
Yeah, Tilde.
Tilde Ann, please. Yeah.
Hi, I'm Tilde, and I'm here today to talk to you about JavaScript linting and how it's like Star Wars. So, what is a linter? A linter is a tool that uses static code analysis, inspecting your code when it's not running, to enforce coding conventions. How do they work? Linters use an abstract syntax tree, which is a data structure that describes your code. I'll walk you through a simplified example. So let's say we have a statement, let x equals 1 plus 1. The abstract syntax tree would look something like this. So the whole thing is a variable declaration. Let is a variable declarator. We have the identifier x, an operator, and two literals, 1 and 1. In JSON, that would look something like this. And so let's say you're going to go through your code and have a whole tree of nodes that allows you to walk through the tree and do things like, if it's a variable declarator and the name is less than 2 characters long, throw an error. Because I think we can all agree that variable names should probably be more than 1 letter long. Anyway, why should you care? Well, nobody wants to waste time during code reviews arguing about code style. So linters are good for that. But it's not just style. You can lint against all kinds of things. You can lint against performance anti-patterns, like using bind instead of JSX props. You can lint for accessibility best practices, like don't point your links to pounds. Okay, so linter is really powerful, cool, but with great power comes great responsibility. If linters let us enforce good code style, then what even is good code style? All right, like, deep question. So I like to think of good code style as like kind of like a continuum. On one side of the continuum, there's like, really objectively good things like the performance thing that I mentioned earlier. On the other side, there's things that are a little more subjective, like brace style or line length and things like that. If you're not careful, you can end up using linters to enforce your arbitrary subjective whims on other people. Why is this a bad thing? Well, it could be a big waste of time. Like, who here hasn't spent some time fighting with a linter at one point or another? This is especially bad for beginners because they're probably going to spend more time fighting with their environment and they're not going to understand how to fix things as effectively. Although auto-fixable rules and good documentation definitely helps with that. So the question of what is good code style is even more contentious in JavaScript, because JavaScript changes all the time. Don't judge me, but I've been writing Java for the past 5 months. Came back, I was like, oh, JavaScript, I missed your sweet embrace. And then I was like, oh god, everything's different, wow. Anyway, wasted time is not the only material harm that can come from, linter misuse. Story time. So, I work at Pinterest. Pinterest started out as a Python shop. So, all of our code, including JavaScript, had 4 spaces. Time went on, and we grew, and the team that was in charge of web platform and standards, they got tired of answering the same questions over and over again about style, right? And that's legit. So they decided we're going to move towards a community standard of JavaScript, whatever that means, which actually what it means is adopting Airbnb style guide. I mean, totally reasonable in practice, or in theory, right? But in practice, before you can actually enable a lint rule, you have to fix the existing instances that are not compliant in your code base. And our code base has gotten quite large. So one day, someone landed a very large code mod in the middle of a workday to change from 4 spaces to 2 spaces. And, well, merge conflict party. People got mad. And understandably so, right? It was really disruptive. It would have been much better to have communicated proactively about this change beforehand, not landed it in the middle of a workday, and provided auto-fixing tools that worked. But I don't want to throw shade. The team behind this, they didn't have bad intentions. They were trying to make Pinterest better, but I think from where I was sitting, as someone who's trying to land a feature that day to make a deadline, they lost sight of the goal, which is really easy to do as programmers because we have to keep track of all these little abstractions, all these different things. Well, how can we avoid losing sight of the goal? As our last speaker said, empathy. I know, it's just a buzzword these days, but it's a buzzword for a reason. So, Linters are one kind of developer tool, but I'm going to take a step back and discuss kind of some social patterns that impact developer tools more broadly. And by developer tools, I mean like internal-facing things. So if you're building tools for internal customers, you're going to be kind of scrappy and under-resourced, probably, because the most resources always go to the thing that makes the business frontline money, just the way it is. If you're building internal tools, your job is about building relationships, because it's not like you're building for some abstract user story. The people you're building for are right there in the building, or your company, probably down the hall from you, fighting some of the same battles. And it's important to listen to their needs. The thing is, most companies suck at doing user research, or even for their external customers. If they do it, they don't necessarily listen to the researchers or implement their recommendations. And that's just for external customers. Does anybody actually do user research or testing on internal developer tools and workflows? I don't think so, but we should. Developers are expensive, and little gains here, multiplied over time, add up to a lot of savings in the long run. Also, if you're building things for people who work in the same company, user research doesn't have to be heavy. You can just sit with someone for a little bit of time. Watch them try to use the thing that you made. I came in here all prepared to hate on Airbnb stuff. I took my bad experience with it, but actually, they're pretty reasonable and empathetic. This person opened up a GitHub issue to ask, hey, which lit roles do people typically disable? And then had a well-reasoned, moderate discussion about it. Good job. But, okay, so what does any of this have to do with Star Wars? Not as much as I'd hoped when I wrote this abstract, to be honest. But, okay, I was going for this thing when I wrote it, ESLint and the Force both have a dark side and a light side. But you know what? Fuck that, because talking about things in terms of good and evil is reductive. I don't want to build up binaries, I want to break them down. So, I want to think like this. Unless you're talking about Jabba the Hutt, who's actually evil. Fuck that guy. I tried to save it with some memes, but it just wasn't going to work. But anyway, I don't want JavaScript to be or I don't want linting to be or developer tools to be like Star Wars, because Star Wars is a study in dysfunctional relationships. We got daddy issues, we got abandonment issues, we got, bad marriages. I like the whole set. So instead, in an idealistic world, I'd like developer tools to be more like Steven Universe. Yeah. So, if folks don't know or haven't heard of it, Steven Universe is a cartoon about feelings, basically. It's like developer tools because the main protagonists on the show, the Crystal Gems, they're scrappy as fuck. They save the world time and time again against an enemy that is more powerful and has more resources than they. Also, Steven Universe is a model about how to use empathy and, to resolve conflicts and have good, healthy relationships with people. So, what do we learn today? A little understanding goes a long way when you're building tools for internal customers. You write the abstract. Yeah, who am I kidding? I'm going to make the same exact mistake again, I know myself. Anyway, you should all be watching Steven Universe because it's great. Thank you.
see, now I understand why I didn't make any jokes about Bryan's talk, because that was Tilde's job. Because if you notice, we're both kind of talking about the same thing, right? The parallels. I don't mean like competition, but like the parallels, you know? The thing that really struck me the most about what you said is where you were talking about how like internal tools are often the most starved for resources. That's true about us too. Like our internal tools, we're just constantly focused outwardly, dude, soft tabs, what the hell, but like really, like we're not thinking about why am I so hard on tabs, seriously, like, think about it a little bit. And maybe you'll discover some insight, to yourself as well. So thank you very much. That was perfect. It was a perfect segue. So thank you, and welcome to the very first evening of Empathy.js. Because apparently that is all we are here to discuss. So please go and talk about your feelings and enjoy your mission.
That's perfect, because my next song is from Steven Universe. And now we heard the introduction.
I was gonna go and I was gonna do this. I'm gonna bring up.
Oh yeah.
Kind of tempted to just do this and just put on Steven Universe.
I know.
Double check it again, though.
Yeah, I realized the slide, like, I was like halfway through the presentation, so I was like, move back to the first slide. You know, the usual stuff.
Yeah. It's like shimmering with me.
What?
You're shimmering with me.
It's just because it's like shaking. I mean, it is chilly. It's harder to like stay warm. Thank you. I always write that and I never look at it. There's so many boxes being like, I know they're there. It's a security thing. It's ridiculous. It works.
You can double check it. Alright, fine. Actually, did you want the...
Sure.
Close this. Don't hit yet. Okay.
Oh, right.
And let's play your beer.
I don't want to spill it on my laptop. Okay, perfect. I know. It's like, wow.
The show is up.
So, it was cool that Tilde mentioned Steven Universe and that it's still there because the second song is from Steven Universe. And for anyone that doesn't know the show, I have to explain how the song came about because it's really cool. At the end of each episode, in the credits, they would play like 10, 15 seconds of music, and it would be the same thing over and over again for like a few weeks, sometimes even months. And then it would change a little bit, it'd be something else. And eventually people realized that all these little things put together would turn into a song. And then after like a year or more, we had the whole song. And it's a really good song, so I'm going to sing it for you. It's called Love Like You. And I think it's written by Rebecca Sugar. If I could begin to be half of what you think of me, I could do about anything. I could even learn how to love. When I see the way you act, wondering when I'm coming back, I could do about anything. I could even learn how to love like you. Love like you. I always thought I might be better. Now I'm sure that it's true. 'Cause I think you're so good. And I hear you. I always thought I might be better. Now I'm sure that it's true. 'Cause I think you're so good. And I'm nothing like you. Look at you go. I just adore you. I wish I knew. One day, see you think I'm so special. If I could begin to do something that does right by you, I would do about anything. I would even learn how to love. When I see the way you look, shaken by how long it took, I could do about anything. I would even learn how to love like you. Oh, love like you. Oh, love like you. Love me like you.
Absolutely fantastic. Tickets are on sale now. I think she's got albums here as well. If you would like to pick up an album, please stop by her Rooch. Stop by her her merch booth. One of the two. I will be merching that, so I'm told. Not really, I was just making that up. I'm sorry. So I guess Empathy.js has now moved on to simply Steven Universe greetings. Which is cool. I mean, I'm not complaining. I haven't seen the show. Does that disqualify me from anything? I feel like that's admitting that I'm like a bad ally or something. I promise I've been meaning to binge watch it for a while. If anyone has any watching tips, things I should know beforehand going into the series, I generally appreciate that kind of information. So, where are we? Intermission is done. We're done with that. We were serenaded, we socialized, we refreshed. Show of hands. How many? No, show of hands. How many of you are refreshed? Sorry, I didn't need it. So you got refreshment. That's good. Nice few patrons here. I'm pretty much solid. Are you ready? You're ready.
I'm ready.
You were born ready. All right. So everyone, please give a warm round of applause for Vaidiki.
Yeah.
Yeah, right, the light is breezy. I gotta figure out where to stand. Okay, don't go towards the light. Not today. Okay. Hi, everyone. Okay. I can't do this talk if you're gonna look at me like that, so I'm gonna try it again. Hi, everyone.
Hello.
Thank you. My name is Vaidiki, and I'm really excited to be here. Partially because I've heard really great things about Waffle.js, and partially because I'm from Portland and we have like a heat wave going on there, so I'm really stoked to not be in like 107 degree weather right now. But what I really wanted to tell you guys today is that I've discovered that there are a lot of different ways to do something. Uh-oh, that's very white. You can see, okay, good. There are a lot of different ways to do something. And this is very true for our code. It's very true for the software that we built. But what I have learned, maybe some of you already know this, it's super true in computer science. So I don't have a computer science background. I'm actually a writer turned programmer. But I took it upon myself this year to like teach myself computer science in a year, which is kind of crazy, but I'm gonna try. And I have been basically learning all of these interesting things about computer science that I never knew, but that I interact with every day. And one of the things that I've learned is this amazing number called 16. Yeah, who in the audience, I love you. I don't know where you are. Like, you are speaking to my soul right now. All of you should do at the end of this. That's my goal, make you fall in love with 16. So it turns out you can write numbers in a lot of different ways. And in computer science, it turns out that it really just depends on how many digits you want to use to represent numbers. So most of us are familiar with, 10 digits to represent a number. You might not know this, but this is also called base 10. Pro tip, if you really want to impress somebody, that's called the denary number system, which I didn't know, but is it denary? Denary? Just make sure you say it with confidence, not like what I just said. They'll believe you. So you can write numbers with 10 digits, but you can also write numbers with, you can write them like that. Oh my god. It says 205. See that there. Okay, so you can write numbers with 10 digits, but you can also write them with 2 digits. This is called base 2, or the binary number system. The number 205, represented with just 2 digits, is 11001101. A little bit of a mouthful. But you can also represent a number with 16 digits. This is called base 16, or hexadecimals. But how do you represent the number 205 with 16 digits?
Seems strange. Let's find out. Well, in order to really know how to represent something in base 2 or base 10 or base 16, we kind of have to understand what we mean when we say base. So base refers to how many digits are possible for any place value. So base 16, we'll work our way up. Let's start with something we know that's easy. Base 2, 2 possible digits, 0, 1, that's it. You can only ever use those digits. Base 10, okay, we've got some more to work with. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How are we going to do this for base 16? Well, we have 10 digits we can use, 0 through 9. We can use sliders. Actually, that's exactly what we're going to do. To create 16 digits, we're going to use the numbers 0 through 9 and also A, B, C, D, E, F. For the rest of this talk, do not think of them as letters because they're numbers. So I said so with confidence. Okay. So 205 in base 10, 205. 205 in base 2, 11001101. 205 in base 16, CD. Yes, really, I looked it up. You can look it up too, I'm not kidding. CD. Okay, so when we had only 2 digits to work with, in order to represent the concept of 205, we needed 8 place values, 8 digits. When we had 10 digits to work with in base 10, we could represent that same thing with 3 digits. In base 16, we could represent the same concept with 2 digits. Hopefully you notice that as the base goes up, the number of digits you need to represent something goes down. This is kind of cool. You'll find out why in a second. Okay. It's kind of cool. But why does that matter? Well, it all comes down to this fact that as you need more digits, you need more space. So if you can represent something with less things, with less digits, you're saving space. That's pretty much the only idea that we're working with here. So when we have this written in binary, each one of these digits is also known as 1 bit. The word bit is actually short for binary digit. 8 bits, 8 binary digits, make up 1 byte, which we don't really think about as programmers in the concept of ones. We think of them in much bigger numbers, but that's really what they are. So if 8 digits is 1 byte, 8 digits in binary represents 1 byte. If we can do the same thing with hexadecimals, we only need 2 digits, and we're still representing 1 byte, which is awesome, because who cares about 6 extra digits? They can go away. Totally unnecessary. The fewer the digits, the more information we can actually represent in a tiny amount of space. And this starts to be really powerful, and it's one of the things that shows up not just in computer science, but in something that we all deal with all the time. So, it's a great idea. I don't know who came up with it, but it's really cool. How many of you have to write CSS? Me too. Okay, when you write CSS, how many of you would use this format to represent the number? Okay, that's like around half the room. How many of you would use this format? Wow. Really, no one? It's okay. Maybe there are some people in the back. It doesn't really matter what you use because it turns out they're equivalent. And there's some cool 16 magic stuff going on between these 2 things. So, both of these 2 representations will give you this beautiful red. So, if we look at the first representation, this is actually known as like a hex code or a hex value, and it really contains hexadecimals within it. So if we look at 2 consecutive digits Remember, 2 consecutive hexadecimal digits represent 1 byte. So let's look at the first byte of information. The first byte of information is 2e. Well, this is in base 16. Let's convert that to base 10. In base 10, 2e is the number 46. The next consecutive pair of digits, 15, from base 16 to base 10 is 21. EC in base 16 when converted is 236 in base 10. Do these numbers look familiar? Yeah, good. Someone should pay attention. Because that hex code, when you convert those numbers from base 16 to base 10, give you the exact same numbers in the RGB representation of that same color. So, 3 bytes of information, and we're representing a whole color. And instead of 8 plus 8 plus 8 binary digits, we're doing just 6 hex digits. So what's going on inside of this RGB representation? Well, we're looking at how much red, how much green, and how much blue we're adding to make that color red that we saw before. What's really cool is that if you're like a color nerd like me, you know that this is something called the RGB color map model, which like computer screens, TV screens, and like I don't know, a lot of other things have this concept of added color, where you basically say how much red, green, and blue you want to add, and you can kind of think of it as like the volume knobs, and like you kind of turn up how much of each color you want to add to create another color. And if that kind of thing is interesting to you, you should look up the theory of trichromatic color vision, because that is what that's based on, and it's like from the late 1800s. It's really cool. But the idea here is that if you add all of red, green, and blue, you get the color white. And if you remove and have the absence of all green and blue, red, green, and blue, you get the color black. If you remember, in hexadecimals, the smallest digit is 0, and after 9 comes A, B, C, D, E, F. So the highest possible digit is F. So if you turn up the red, the green, and blue, you go all the way up to F on all 3, which is why white is represented with 6 Fs and black is represented with 6 zeros. So, okay, we have 3 bytes of information. Each one of these is a hexadecimal consecutive digit, which is 1 byte. And in each of these 1 bytes, we have 16 possible permutations for each digit. So that's 16 times 16 for each byte, which means 256 possible values of red, of green, of blue. That's also why if you've ever accidentally typed in RGB representation of a color and you did like 256 instead of 255, and then you got a crazy CSS error, it's because you can only go from 0 to 255. Those are the only possible permutations. So, I don't know how good your math is, but 256 times 256 times 256 would give you the possible permutations of all the colors. That's over 16 million colors in our color spectrum that we are representing with just 3 bytes of information, which is pretty wild. So, hexes aren't just in your colors, they're actually everywhere. They are in ASCII encoded, which is something that's super popular and extremely important to use if you are representing languages that are beyond English. They are also in hexspeak, which is kind of like back in the 80s, programmers used to come up with these unique values, and it actually became the foundation for LeetSpeak, where they would do like things like dead code is one, dead beef is another one, and the E's would be like 3s. But they would basically like use these magic debug hex codes, and whenever something errored out in their program, they would use these codes, and then they wouldn't have to like search through this crazy long error. They would just see dead code, and then I guess it would mean something to them. Doesn't mean anything to me, but I guess it has some meaning. But that's also hexadecimals. And in the IPv6 IP addresses. I believe they are 8 groups of 4 hexadecimals at a time. Those are just text codes that are used to identify your computer. So, most of us type this into our computers. We do not type that. Thank God. But at the end of the day, that's what it gets compiled down into, right? But what's really cool is that the fact that we can type the first thing and not the second thing is just purely an abstraction that we're leveraging. And I feel like in all the things that I've learned about computer science, it's really just that. Abstractions are just abstractions. They're not magic. And I think that's really, really important because abstractions can be a huge barrier of entry for someone who might be new to our industry, to a language, or to learning computer science, like I am. But when you start to unpack them and see them for the little bits and bytes that they are, they become a lot simpler. Understanding abstractions is what makes them magical, not the abstractions themselves. And I think that's a huge, huge thing to overcome when you're learning something new, especially in our industry. So, if you find this kind of stuff interesting, you should definitely check out my project for this year. From January until December, I'm writing about a computer science topic every week. It's August now, so I guess there's only 4 more months to go. You can check it out at medium.com/ACS, or if you are on Twitter, you can see my pinned tweet, because I publish every Monday. So maybe come learn about cool abstractions with me and nerd out about colors, because that's what I like to do. Thank you guys so much.
The thing that I thought was particularly interesting is that was a very colorful talk. I mean, slides aside, that it really puts things in perspective. And the thing that I got out of it, because I'm not really all that good at numbers, is like, the way that you think of these things, like there's base 2, right? That's binary. You know that. And then there's base 10, or binary numbers, And then there's base 16, which that's like the number system your mother warned you about in high school, right? Stay away from those hexes. And of course, I didn't listen. Look at me now. But yeah, I think, and the one thing that you mentioned, just in passing as well, wasn't even super relevant to the topic of your presentation, but I think had a common thread to the previous 2 talks. And you said, and I quote, "because I said so with confidence." And I got to thinking, that's basically how everything happens in this world. Somebody is like, "I said so." And I think the lesson that we can learn there is, obviously, the theme or there, like empathy is important. But sometimes you just gotta be willing to say so with confidence and just be like, that's reason enough. Whoa. So anyway. Chandler, how are you?
Hello, I'm doing pretty good.
Good, glad to hear it. Is there anything that we should know about you before we get started?
Well, I guess my name is Chandler. I'm a software engineer and I do imaging science and space photography and color stuff at Planet Lab just down the street. And for about the last 2 years, I've been on this sort of crazy mission to make myself a color scientist for some reason. So I've got a little bit of that to share with you today, so I'm pretty excited.
Well, you just introduced yourself. So I'm going to sit down.
Cool.
And then everyone can applaud, and then you can get started.
All right. Well, first thing, I couldn't have been set up any better. That was perfect. Talking to you about color. So this talk is about RGB color. It's called Chapter 4 Spark Notes. It's not really the beginning, and it's not really the whole story, but it's a really interesting part. And I'm just going to kind of drop you in the middle of something that you're not going to see very many other places if you read about color, and hopefully tickle your mind a little bit and give you something to go look into further. So,
wait, I have a clicker. I can do this.
Yeah. So. Yeah, I just hope you come away with this with a little bit of a intuition for how RGB colors fit into a bigger picture, which is the human visual system. So we need to talk just really quickly about the geometry of RGB color. You sort of already heard that there's 3 values. They usually range between 0 and 255. Sometimes they range between 0 and 1 in their floats. It's the same thing. Each value is called a primary. So R, G, and B are primaries, and they actually tie to like a pretty physical abstraction. The abstraction is lights on a wall. So if I had 3 lights and I shine them all on a wall and they're sort of reddish, bluish, and greenish, you'll get a white. And if I shine a red light and a blue light on the wall, I get this magenta. And that's the same thing as saying R primary 1, or R is 1, G is 0, and B is 1. This is a model that models real lights on a wall. So this ties to something very physical. It also has an interesting geometry. So maybe you've seen this before, but like this it's very common to represent this as a cube. So you say, okay, each of the RGB primaries are a dimension in 3-dimensional space. If you fill up all those 16 million values we heard about earlier, these are all the possible colors, and it makes this nice cube. If you take just a slightly closer look at that without all the sides filled in, just look at the edges, you can kind of see there's some more interesting geometry in the middle. The line from black to white is like all the possible grays, so right in the middle would be like 0.5, 0.5, 0.5. Up here in the corner, cyan, you can see it's 0, 1, 1, white is 1, 1, 1. So that's red, green, blue all mixed together. So there's actually sort of a different way to think about this, which is like if you treat each dimension as this arrow, and then you sort of add the arrows together, the resulting color is the new arrow that points to. So if you've taken a lot of math in college, you might recognize that this is basically vector addition. So each primary represents a vector and its dimension. And you kind of see this cool 3D thing here. If you add all 3 of those arrows together, you sort of get this other arrow that points out towards white. That's the vector that you get by adding R, G, and B when they're at full length. And so if you don't turn on the green primary, if you didn't turn on the green light, the vectors would just add to this space. So we've got a nice mathematical operation that's again describing a real physical thing you can do with lights. But I haven't really told you what R, G, and B are yet. I just said reddish, greenish, and bluish lights. So keep that in mind. It's basically vector addition. I talked about that. So this whole thing seems suspiciously tidy. Does the real world, does vision really fit into this perfect cube? Is it all, the universe just worked out that way? And the answer is not really. So enter trichromaticity. You heard about this earlier. Let's talk a little bit about this. Inside the eye, there are 3 cells there's these cells called cones, and they come in 3 types. Each type is sensitive to sort of a different part of light. So at the bottom here, the x-axis is the wavelength of various parts of light, so 400 nanometers to 750 nanometers. This is sort of the range of light that we can see at all. And then you can see the 3 different curves here are the sensitivity of the 3 different types of cones. From the left to the right, they're called short, medium, and long cones, because this is the 400 nanometer, it's shorter than 700 nanometer. So you've got these 3 cells, and any light that hits your eye basically stimulates all of the cells, but it's depending on the power in the different parts of the spectrum, it's going to stimulate the cells differently, more or less. So if you have a lot of energy in the blue part of the spectrum down here, it's going to stimulate this cone more than these 2. So I think I've got a diagram of that right here. So this is the spectrum of light falling on a spinach leaf. It has a lot of energy coming off it in the 500 range, so it stimulates the red and green cones quite a bit, not so much the blue. And so basically your eye takes this very complex spectrum coming off the spinach leaf, the black line, and it converts it down into this 3-dimensional representation, these 3 numbers. So if you integrated this line against these 3 cones, the blue value wouldn't be quite as big, the green value would be a little bigger, but it's covering the red cone the most, so that's the highest value. So all light has to sort of be smashed down through the system in the retina before it gets passed on to the brain to do more interesting things with. So if we're building a color space about this, you might think, well, there's 3 things here. There's these 3 cones, long, short, medium, long, usually called long, medium, short if you go right to left. You could assign each one of them, again, a dimension of 3D space, and you'd be like, well, okay, we've got a cool cube. Every possible value that could come out of these 3 cones can be represented just like the RGB color space. But you've got a big problem. The cones overlap. They don't all represent their own unique part of the color space, which sort of puts a little quirk in things, because this point in an RGB cube represents when green is stimulated by itself. It's green 1, red 0, blue 0. But if you notice here, you can never stimulate just the green cone, because it overlaps completely either with the red or the blue. So no light hitting your eye ever is just green by itself. It's always green and some red or green and some blue. which means if you want to make a cube and a color space out of these cones, it's not going to be completely filled in. It's going to be this weird shape in the middle. And it's really cool, and I've graphed it for you. Wait, next slide. Okay, so this square, usually there's some lines here, but projector you can't really see it, but this is like a cube. And this, oh, top, yeah. So this cube represents sort of the ideal LMS cube. It's all each dimension is one of the cones. And then this crazy waffle cone in the middle is all the values that can actually occur in real life. And so this is like the surface, the boundary of all the possible values that your cones could ever realistically be stimulated by. And I haven't filled in the middle, but you could kind of imagine like holding a waffle cone and something you could like put a scoop of something inside there. Everything inside of this boundary is a real value that the eye could really sense, and everything outside of it could never happen. So you kind of notice it doesn't get anywhere close to this corner of the cube, and that's because this would be the green corner. So if you could stimulate the green by itself, this sort of object would come all the way over here, but it doesn't. And so it sort of just stays in this little circle. And that it's kind of interesting that the blue almost does come up to the corner. And that's because the blue, you can almost stimulate it by itself. It hardly overlaps with green here, so you can almost get a blue-only signal, which is why that part comes up, this part doesn't, which is sort of the most interesting part of this talk. So, okay, this is all really cool. This is great, but this RGB cube from earlier is very useful, and we kind of want an RGB cube still. So we're kind of like, how can we make an RGB cube out of this? And the answer is we kind of just decided maybe we'll just like chop a cube out of the center of that cone and forget about the rest of the colors and just roll with the cube. And so what does that look like? So what we did is we picked 3 reddish, greenish, and bluish points that are technically inside the waffle cone. So they represent real values that the eye could really have, and they're sort of spaced out. It's 3D, so it's a little hard to tell. And we said, okay, the line between the origin and one of those points, those are going to be the new dimensions of our cube. And they're not like 90 degrees from each other, so they're not like a real cube, but we can still do all the same math. So you can kind of see here, if you added these vectors together in this space, you get like the white one, and if you made them a little smaller so that they weren't like the lights weren't fully on, you get like this orange color. And so we can do all the same math that we want to do with this RGB cube, and here's them kind of together. These are the real primaries of sRGB color space on the web. This is how they fit in the real sort of physiological color space of your eye. And this is how you know what RG and B are. So if you're like, okay, it's RGB, but what is R? Well, if you go look it up, you can be like, R is a light that stimulates your retina with this coordinate value. And you can pick any light you want, as long as you've got that one that stimulates the eye in that way. You can use it and shine it on the wall, and you can do real sRGB math on the wall with those lights, if you get the right lights. And since this forms a cube, like we talked about earlier, these 3 dimensions form this nice cube, it's kind of cool, is this actually forms not a cube, but this like sort of smashed cube. It's like I think it's called a parallelepiped or something, but it's still got 4 corners, but it's not even, so it's this like weird cube thing. And it's kind of cool because it's nestled inside this cone. So it contains most of the color values that are possible with the retina, but not the ones like right at the edge of the boundary. You can still like stick your hand under there. And so we picked these primaries, and they're this is the primaries over here, and this cube is just, if you turn those into axes and turn it into like a 3D object, I guess it's not a cube, you get that. And so basically, once you've got this is sort of really what sRGB color space looks like. I guess this is the better picture because it's nestled inside here. Later, you just do a little bit of linear algebra and you squish it back into a uniform cube, so that you get these nice even dimensions, and you're like, okay, that's sRGB color space. And I guess the takeaway here is that sRGB color space covers a lot, but not all of the possible colors, which is kind of cool. Right, spectrum. So these are the key takeaways. The spectrum doesn't, the LMS cube doesn't reach the corners because spectral overlap. It's a partial part of the cube. Takeaway number 2, RG primaries are defined relative to cone values. So really, it's a color space of lights, but its basis is in the retina. It's a retinal color space. And also takeaway, the gamut doesn't fill up the whole thing. So I think I've got time for one little cool demo because I'm going to show you how this relates to what you will see on Wikipedia, so you can put it all together. So if you've ever seen this picture, this is what you find on Wikipedia. It's like, oh, this is the sRGB gamut. It's this triangle inside this little flat thing. And you're like, what is this flat thing? I've never seen this before. And how? This seems like it's a 3D problem. How did they get it into 2D? And I will show you very quickly how they got it into 2D so that you could be confused. So what they've done is they've taken the cone that I've drawn and they've drawn a triangle that connects at points 1, 1, 1. It's called a unit triangle. And they're like, okay, you see where this cone intersects this triangle? Let's just like slice that part of the triangle out and then use that triangle as just the 2D view, and everyone will understand that it's a 2D triangle projection onto the unit triangle. And then they're like, okay, here's what we'll do. To represent the gamut, we've got this big cube. Maybe if we just stab it through the triangle, and then we'll kind of just arrange it like this so you can look down, and everyone will realize they're looking down at the bottom end of the LMS gamut. And then if you look at it side to side, you will see that, in fact, they look pretty similar. So this is the chart, and this is this is the 3D sort of proof. You're looking at you're looking from the other side actually, but the spectral cone carves out the shape that you see, and then the triangle, the gamut cube sort of pokes the triangle through. So if you're ever wondering what that is, it's that. So it's really great. All right, so the last two slides, this stuff has been known for a while. So here's an 1857 quote: colors corresponding to those parts of the triangle beyond this curve must be forever known to us. This is James Maxwell. He realized that there were color coordinates in the cone space that could never be seen because they couldn't be stimulated with real light. So there's these imaginary colors. This is an old idea. My favorite quote when I was making this slide is the observation from Riemann, another famous scientist that Riemann sums Riemann integrals. He notes that it's pretty amazing that colors follow all of these amazing geometries, and that colors and objects in 3D space are probably the only two things familiar to us that follow such geometric rules and that work in such an elegant way. And he brought that up 150 years ago, which I thought was pretty cool. So I think I'm done. So thanks.
I don't know. I mean, you said you're done, but I feel like you're going to keep going.
Oh.
You know what I mean? Like, I feel like it just scratched the surface. This is good stuff. And one of the things I thought was really interesting is you mentioned that in terms of visible light, like what our eyes can see, that's from about 400 to 750 nanometers, right?
Yeah.
That's interesting. I had never really had any reference to that other than like the little laser diodes that I burned my retinas out with as a kid. But like, I did some math, and you know, like 400 to 750, that's just in denary numbers, right?
Yeah.
It's actually 190 to 2 nanometers in hex, which, as we know, is the superior number system. So,
way superior. Right.
Yeah.
I'll change that.
So if you do that, that would be great. And then, like, really the takeaway that I got from that talk, I mean, you made a lot of really interesting points, but like, I think what really hit home for me is that, like, if you really want to actually explore color space, you gotta be willing to like stick your hand into that space that exists between the cube and the watercolor. And I think again, like, not to like stretch, you know, the symbolism too far, but isn't that the way everything in life works? I mean, really. So anyway,
you gotta empathize with that space.
Yeah, exactly. See, bring it home.
Fit in there.
So yeah, thank you to our wonderful speakers. Please, a warm round. And as a quick reminder, you should perform at Waffle.js.
You should.
Totally should. And you can chat it up.
Oh yeah, this is just a promo. You should chat with us on Slack.
Yep.
It's fun.
It is. And now it's beverages.
Beverages. Karaoke, 1 block away.
Yeah. And then, you know, so a couple people have been coming up and asking me about like the history Waffle.js. And I think it makes, like, now is a good time to kind of talk about it. I got a couple questions. One, why is it called Waffle.js and you have donuts? And the answer is, those are torus-shaped waffles. Come on, we're talking about shapes and geometry and stuff. No, actually, it turns out people like donuts. So we did that. And then also, fun fact, little piece of trivia, we did not always do karaoke at Butter. Where was it before?
Rumors.
Right, it was this place, Rumors. It claimed it was like some karaoke bar out there. I don't even know if it exists. I mean, that's what they say. But this place, the place we go to, not only is it much closer, it is much better as well. So you should definitely come hang out with us. They have got some choice theme. And Roger Niner is also there as well, the KJ. He's super cool. And I said this last month, and I will say it again. If you go, maybe you don't feel like singing your own karaoke, request that Roger Niner sing a Tori Amos song. And it is special, very special. So anyway, that brings us to garbage collection. So it should be pretty self-explanatory. Stop the world. Come on. No, but really, basically, if you see things that look like garbage and you feel you fancy yourself a collector, feel free to take it home. We don't mind. Or alternatively, you could put it in the appropriate receptacle, and that would aid us greatly in getting over to beverages a lot sooner. I don't know if you have anything you want to add.
No, literally. There's three receptacles.
3 of them, just like the different kinds of cones in our eyes. Fancy that. Life is full of patterns. So maybe you can recognize other patterns on your journey to your garbage collection and waffles, or you already did waffles, and karaoke. Whoa. My life is flashing before my eyes. All right. Be free. Thank you.
Garbage collection is well seen. Yeah, it was. Yeah.
I don't know how that works
Empathy and colors, also numbers. They're all kind of related.
They're all like flowing into each other.
Yeah. I'm telling you.
How's well
So Waffle.js is slowly turning into Metaphor.js. Alright.
Can I throw these away? Like, they don't really have proper recycling. Yeah. I'm gonna hit stop.